Okay, this is the notes for section 7.4. Make sure that you've gone through, and when you did your reading you should have filled out the vocabulary at the top of these notes. I'm not going to be going through that, but if you have any questions about any of those vocabulary terms, make sure that you ask about them in class next time. Okay, this is a section on compound interest, and there's two formulas that we're going to look at: the annual compound interest formula and then also the general compound interest formula. You'll need to know both of these formulas. First of all, the annual compound interest formula is the more basic of the two, and it just says if we let P be the amount of money invested at an annual interest rate of R compounded annually, let A be the total amount after T years, then A is equal to P times 1 plus R raised to the T. So let's take a look at this first example. It says you invested $500 in a savings account that pays 3.2% interest compounded annually. How much money will be in his account after 5 years if no deposits or withdrawals take place during the 5 years? Okay, so there's some information there that we have to be familiar with. The fact that we started with $500, so that would be your P value. The interest rate is 3.2%. Remember what that means, that the R, we got to write that as a decimal, would be 0.032. Okay? And we know that the amount of time that they spent would be in 5 years, that the money was in the account was 5 years. So if we're going to do that problem, then if we're going to lay that out, it's going to look like this. So I'm going to put 500 in for P. I'm going to put 1 plus 0.032, the rate, and then raise to the 5th power the time. If I go ahead and plug that into my calculator, I have $585.29. Okay, the second interest formula that we have is the general compound interest formula. And the general compound interest formula says the following. It says let P be the amount invested, just like before, at an annual interest rate of R compounded n times per year. There's the difference. Where we instead of compounding it only once per year, when we're using the general compound interest formula, we're going to have a number of periods that we're going to be compounding that interest. So that value is n. And then let A be the amount after T years. So the formula for that would be A equals P times 1 plus whatever the rate is divided by the number of periods, n, raised to the n times T. Alright, so let's take a look at this second example here. It says Debbie invested $5,000 in a 5-year CD. Okay, so the $5,000, that number there would represent the original amount that we invested, or P, in a 5-year CD. So that would be this 5 years would represent the amount of time in years that that money has been invested. Okay. It pays 7.8%, so there's your R value. So once again, this is T, this is R, this is P. Okay. Compounded quarterly. Well, quarterly tells me that my N value is going to be equal to 4, because if I'm compounding it quarterly, I'm compounding it 4 times a year. The CD matures next February. If no deposits or withdrawals took place during the 5-year period, how much will the CD be worth when it matures? Well, when it matures is the value or the amount that I'm going to have in the account after that 5 years. Okay? So what I'm going to do is I'm going to take each of those values and plug them in to my formula up here. A equals P times 1 plus R divided by N raised to the NT. If I do that, okay, I'm going to plug in 5,000 for P. I'm going to plug in 0.078 for R. Remember, if it's 7.8%, that's the same as 0.078. I'm dividing it by 4 because we were our n value is 4 for quarterly, and then I'm going to raise it to the 4 times 5. 4 for n, 5 for t. If I do that, I have 5,000 times 1.0195 raised to the 20th power, which is equal to, and you can check this on your calculator, $7,357.23. So let's take a look at example 1 here. It says suppose $1,000 is deposited into an account that pays interest of 3.5%. How much will be earned in the first year if the interest is compounded as indicated below? Well, the amount earned would be the interest. Okay, so the interest is equal to whatever the amount in the account is minus whatever I started with. So if I look at it annually, the amount in the account is equal to 1,000 times 1 plus 0.035, well, raised to the first power. And then the interest, so that would be 1,035. Therefore, the interest is equal to 1,035 minus 1,000. Therefore, the interest is equal to $35. Okay. Now, if we look at it semi-annually, we have to use our other formula to do that. However, the idea of finding the interest being the amount minus the principal is still the same. So now my amount is going to be equal to that same 1,000 times 1 plus 0.035 divided by 2, because there's 2 periods if I'm doing it semi-annually. And then it's going to be raised to the 1 times 2. Okay. If I do that, if I go ahead and figure out that amount, plugging that into my calculator, we would have 1,035.30. Therefore, the value of the interest would be that amount minus 1,000 again, so it would be $35.30. So if we do it semi-annually, we're going to get just a little bit more money than we would the other way. Okay, and then for the last one, I'm going to do the same thing, just a little bit more than we did semi-annually. So the more times we compound the money, the more interest we're going to earn on that money. Okay, the second example says, what is the APY, or the annual percentage yield, for a 4.5% interest rate compounded first semi-annually and then daily using 360 days for a year, which is a fairly common thing to do. So the way that we're going to do that is we're going to figure out, well, how much interest would they earn for the year semi-annually, first of all, and then I'm going to subtract 1 from it. And the reason why I'm using 1 is just to simplify our calculations. I'm going to use a principal of 1. Okay, so what I'm doing here is I'm first of all finding out, well, how much amount, what would be my amount after that compounded semi-annually after 1 year. And if I do that calculation with a principal of $1, I find that it's 1.0455. Okay, therefore the interest that I earned would be 0.0455. Okay, which means that the annual yield on that, the AYP, would have to be 4.55%. Okay, so whatever it is that whatever my interest that I earned for 1 year is, that would represent my annual percentage yield. Whoops, APY, not YP. Okay, finally the last one here. It says a bond paying 7% compounded annually has matured after 8 years, giving the owner $10,000. How much was invested 8 years ago? So this time we're given the amount. What we don't know is the principal. Since we're compounding it annually, we're going to use this formula, A equals the principal times 1 plus the rate raised to the time. Now I'm going to plug in the stuff that I know. I know that the amount after the 8 years is $10,000. I don't know what the principal is, but I know we have 1 plus the rate being 7%, that would be 0.07, raised to the t power. Well, t is 8 years, so I'm going to plug that in there. So simplifying this, I can say 10,000 is equal to 1.07 raised to the 8th power times p. And then if I divide both sides by 1.07 raised to the 8th power, I will have the value of my principal. And that value would be $5,820.09.